Okay, now we're looking at server-side rendering. This is quite an involved topic, so we'll tread lightly through it. We're going to look at, first of all, what it is, specifically how it's implemented in Svelte, and then details on cookies, authentication, and general form handling. So we'll be starting with SSR and CSR. So CSR stands for client-side rendering, which is what we've been doing to date. That is, Svelte by default is client-side rendering. Although there are some SSR elements in it that we haven't really been aware of yet, but they are there. But now we're going to look formally at SSR and what it means. SSR, server-side rendering. It's a reasonably newish approach in front-end frameworks to have a server-side element. It's just coming into React now, but it's not very stable. But SvelteKit was designed with SSR from the start. This means that we can effectively have parts of our TypeScript running in the server. We can even have initial renders of the page happening in the server, and then complete versions of the page delivered back out to the client. That has a number of advantages, including search engine optimization, SEO, and also enhanced security. So we get into some of that there. PageLoad in SSR is the way it works. PageLoad in SvelteKit rather is the way it's implemented. So effectively, we're writing new functions that live in special files that live on the server. Those files, those functions in TypeScript are responsible usually for accessing the data stores, for instance, accessing the database, and they pass data back to the client components, which then render the information on screen. It's a little bit like the way we did it in Happy, in fact. Happy controllers, remember, always running on the server, building up pages, sending them back. Well, this is kind of part of that architecture returning with enhancements in that there's also client-side reactivity occurring in addition to the server-side elements. Now, this affords some opportunities, including enhanced security. We can go back to using cookies again. We remember, we're not using cookies here in the client. We've been storing our sessions in local storage. We've had to do a bit of a dance to get them out of local storage if the page is being reloaded, for instance, and reconstitute the session each time, manually managing it. Well, because we've got server-side code here now in SvelteKit, we can go back to using cookies, the same cookies we used in Happy, because we can build them up on the server. A little bit more manually done, but it's very similar to the way Happy worked. Finally, we need forms in general. We have the login form we're going to do, of course, and we will also have the form for donate itself. All this is done in Lab 23 then. We're going to take the maps, the last one we've done, and we're going to put in server-side elements. That is, we're going to make it SSR. It's our second last donation lab, and at the end of it, hopefully you'll start to see through the fog an architecture emerging that maybe holds out some interesting future simplifications, which we'll do next in the next topic. That is, we can possibly remove the Happy application completely, and because we've got a server-side aspect in this SvelteKit application, we can directly access the database. I'm not going to do that yet because it's a little bit involved in doing that, so we'll just take the first step today. SSR then. To recap, it's a mechanism for running parts of our SvelteKit application on the server side. Those parts, the code that's running on the server side, will be TypeScript, and it may be involved in accessing our API or accessing our database directly. The first render of our pages may take place also on the server, a complete page delivered back to the client, and then updates made to the page subsequently. So it appears quite reactive and responsive. SSR is a reasonably newish topic. It's still coming into React, not quite as stable as it is in Svelte, as I was saying. But SvelteKit in particular was designed with SSR in mind. So let's take a look at that then in more detail. First of all, how we used to think about front end and back end as it originated some years ago. Traditional applications, web server builds HTML pages, delivers them to the client into the web browser, and the browser makes requests, usually form submits or button presses, getting new pages. This is very much the architecture we have already developed in our happy application. Sometimes we use the word server rendered web application. The alternative to this, you can see it here on the right, is what Svelte offers, without Svelte Kit now for the moment, but just Svelte. That is, on the right here, we've got this notion that we've got a web server that's fairly dumb in terms of the application we're downloading. And that application is delivered into the browser complete with JavaScript. And inside JavaScript, we have our Svelte framework intervening, sustaining some of the abstractions we've already seen. And any events that occur are held locally. That is, are interpreted locally. Local function handlers inside the page, handling button presses, mouse movements, etc. And in those button press event handlers, we might be making HTTP requests to an API across the server. So the server isn't really responding to individual pages as the user navigates the site. They're all served locally, rendered locally with inside JavaScript engine of some kind, and we make periodic API requests to the server in that instance. That's the traditional view. Now, server-side rendering is another take on server rendering, but bringing to bear some of the power of front-end frameworks as well. Now, the three main frameworks, or three of the main frameworks currently are React, Vue, and Svelte. And server-side rendering capabilities are appearing in all three frameworks under the guise of meta frameworks, they're called. For React, that meta framework is called Next. So it's React plus routing and other things. For Vue, that framework is called Nuxt. So you see it's a play on what's going on here. And for Svelte, the front-end framework is Svelte Kit. And they're sort of blending Svelte and Svelte Kit, so they're not necessarily using a different logo, but Svelte Kit provides us with meta framework routing capabilities. So what are they? Well, Svelte Kit, Next, and Nuxt provide routing and a thing called hydration. And hydration is a very subtle concept to do with aspects of the page being hydrated, that is, it's receiving data, periodically via API requests or other updates from the server using JavaScript requests. It offers some of the interactivity of front-end frameworks, but some of the wider architecture and benefits of server rendered applications. And it's often seen as providing a kind of best of both worlds solution. Now, what I mean by that is that some of the benefits include possible improved page load. So when a page is to be displayed, a specific route, let's call it, it's highly customizable and it could be completely static. That is, there may be no JavaScript at all on the page, if it's an about page, for instance. This would mean the page is assembled on the server and delivered completely to the client without any further hydration or updating taking place of fields in that page. So an about page would be like that, but let's say something like our page of donations, for instance, mightn't, because that's not static. That data has to come and be updated periodically, so we might need to hydrate the table, but the rest of the table would be rendered statically. Search engine optimization. Well, this means that because the routes are all possibly rendered on the server side, your application may behave just like a website. in which case all the tricks of SEO can come into play, because the web crawlers can crawl it, and using meta tags or whatever else you're going to do to get a good search ranking score on a conventional web page would also apply on your web app. It's possible to get some accessibility and progressive enhancement improvements. Accessibility is essentially how we can deal with screen readers and other ways of making the page more accessible to a broader community than just the standard say able-bodied community. This SSR does offer, again, conventional ways of approaching accessibility become much easier to do. And progressive enhancement means we can possibly be able to cope in environments where there's limited or no JavaScript. So on a phone, for instance, what is a slow bandwidth connection, maybe SSR techniques can deliver a better experience in a limited context. That's also the case for low-powered devices, which would not have JavaScript. Consistent user experiences, again, enable the application to be more flexible in terms of what it's rendering to the client and more customizable on an individual page basis. Let's try and make that a little bit more concrete. Suppose we have a web page, web app rather, here, and there are 3 links on it about dashboard settings, and if you click those links you get to a different page. This could be client-side rendered or server-side rendered. If it's client-side rendered, then when you visit the, let's say, the home page, you get everything. All 4 pages are downloaded, the contents, that is, the JavaScript to render them. And as you press the links are intercepted. They're not going back to the server. They're being handled locally in the client. A new page is being mounted from, let's say, a library that's been downloaded in one go. That's server-side rendering. Sorry, client-side rendering, CSR. Now we could have server-side rendering in exactly the same app, in which case when you visit the home page, you just get the home page, and every time you click on one of the links, you get rendered on a server. That is, you get the complete page built up on the server and downloaded at that point. So it very much would be like, let's say, happy application works, or every link goes back to the server, to the controller, build a new page, send it down. Now what Svelte Kit offers is a bit of both, in fact. If you want CSR, you can have it exactly as CSR I've discussed. Everything comes in one go. If you don't want it, you can have SSR, in which case every page is loaded whenever you press the link. That's that. Or you could have a transitional application, as it's sometimes called, which would be the first time you visit every link, it comes down. But from then on, if it has been downloaded, it will be cached locally, and there won't be a round trip to the server when you revisit the same page again. That's kind of a little bit complicated to get your head around, and it is in fact the default model in Svelte Kit. That is, each page is rendered separately the first time and cached for the second visit. Let's try a diagram that kind of captures CSR, let's say. So in fact, you're going to a website, your pages are being delivered from a content delivery network. These are the kind of networks of servers that websites are often distributed to be closer to wherever the user is. You get the whole lot in one go. All the JavaScript comes down, JavaScript is executed, and you are able to have a user experience kicked off, and then any subsequent data you need is coming down from the server via requests using what used to be called AJAX, HTTP requests. Pages are all assembled locally the first time and placeholders set up, and you're just fetching data, not complete pages, subsequently. This diagram kind of gets at SSR, although it's not terribly successful. In SSR, the server is rendering all the pages on the server side. They're ready to render, if you like. When they come down, then they're displayed very quickly because we don't have any big JavaScript to do subsequently. We may get more JavaScript as the page proceeds, and we may hydrate or update the page with JavaScript, making optional requests further. But the server is a lot more involved than in the CSR mode. in that the server may be frequently rendering complete pages and downloading them for faster rendering on the client. So let's get back to our example here. When you navigate to a new page, SvelteKit is going to intercept the attempted navigation and handle it. It's going to update the page, rendering a new page in the client. If the page is the first time we're visiting, it means it's got to go to the server. The server will assemble the page for it. The page will come down and be rendered. If it's second and subsequent times, in other words, we've already visited this page, then the browser cache will be examined and we'll find locally a copy of the page which we can display immediately without any delay. So SvelteKit is implementing a kind of a hybrid mode in this context. We've the possibility then of enabling and disabling this per route. So we can decide we would like all the application's pages to be downloaded and always held in the client, or we would like the pages to be always rendered on the server. That is, the server assembles the complete page and downloads it to be rendered in the browser itself. Or we can decide on each individual page whether we want CSR or SSR. So that's kind of an overview of some of the terms involved. It's non-trivial, as I'm saying, to get used to the whole concept. SvelteKit tries to simplify it and hide as much of the complexity as possible. We can put in very simple little flags to say what we would like, CSR or SSR, or we can leave them out and get a default behavior, which is a kind of a hybrid of the two. Let's get into some examples of how this can work in a concrete application. It might bring it more into focus. Let's get into the heart then of how SSR works in a SvelteKit application, particularly the role of the PageLoad function, what that does and how it realizes what we're trying to do in this server-side rendering architecture. Okay. We're now, I think, comfortable enough with the idea that a SvelteKit application is organized around a routes folder. That routes folder has got subfolders inside it. See all these ones here. And each one of these folders in turn is a route. That is, the href can contain login, logout, report, donate. And we're going to be then loading something from within this folder when those routes are activated. So there's always going to be one file in there, but there may be more. We've had more already, in fact, but we're about to expand that significantly. The page we're used to seeing here is called +page, +page.svelte, so it's a dedicated file name, and that's the only one we've been using so far as the main root anchor. Inside this page, well, we have our HTML element and we've got our associated script, which is at the heart of how Svelte and SvelteKit work. This is our script. The actual content rendered on the page is here in the HTML fragment. Now, the way this works is that behind the scenes, this is actually loaded on the server, rendered on the server for the first request. And then the result is carried back to the client, and then it remains on the client from then on. So there is some server-side rendering, SSR, taking place first on a one-off basis when the application is initially loaded. And once that has taken place, we then move on to the browser. Everything is shipped over. And the browser then, we proceed to do some work. Now, part of this, though, is to realize that this onMount function is special. That is only loaded in the browser. So if you like, the page is in skeletal form on the server side, and then when on mount, the on mount refers to mounting in the DOM, means that that function is only loaded in the browser, and then in the browser we're calling this function, which is going to go and fill in our map. The map won't really be possibly to be rendered in the server, it has to be rendered in the client, and that's how we've taken this approach here. Here's where it gets interesting though. We can put another file in here. So we can have plus page, and we can also have plus page.ts, a pure TypeScript file. And there'll be no HTML in here. This will be just code we run. We can have a variety of functions in here, but one of the main ones we would put would be a PageLoad function. This is it here. And this function will run in the server once, and it passes values back to the client page svelte. So it's a way of separating concerns, if you like. Page plus page.ts's job is to go and fetch whatever data is needed, pass it on to the svelte page component, and then that data can be rendered as appropriate. So it might look something like this. Inside our PageLoad function, we're retrieving from the API our candidates, and then those candidates are passed to the svelte page, and they're available via the data property. So we see data.donations and data.candidates. So these values here are available over in the HTML svelte component. Again, this doesn't alter the kind of basic principle. These are loaded on the server first. First render takes place in the server. The entire thing is shipped over to the client, and then it's rendered there. This is done automatically for us. We don't have to do any extra work to do it. And we kind of consider the plus page.ts to be the, if you like, the data part, the part that's assembling or requesting or accessing the database or doing calculations, let's say. And then we consider the svelte part to be how it's being organized and made ready in the browser for presentation. Sometimes we might like to alter this flow, and we can say, actually, I don't want anything to take place on the server. I want everything to be done inside the browser. That is our choice, and it is reasonably frequent. We put this field in here in the plus page.tss. We say SSR false. This will mean that this function, PageLoad, will never run on the server. Everything will be shipped to the client, that is into the browser, and both this and the svelte component itself will run inside the browser. Now, there's one more interesting feature available here. If we would like the page to always run on the server and never run on the client, so the page code, if you like, the data fetching component is only to ever be available or running on the server, we can call the ts file page.server.ts. In this instance now, it will be the case that it will always run on the server, and the HTML then will be assembled to be displayed for the client. But the page.server.ts will never be taken over to the client at any stage. Remember, the SvelteKit system is quite sophisticated. The page component runs on the server, then the whole thing is taken over to the client and run on the client again for subsequent updates. If we call the page server.ts, that will be effectively like an endpoint. It'll only run on the server ever. It'll never run on the client. Now, this can be useful for situations when we, for instance, have environment variables. We might have special keys that for accessing a database that we don't want to be visible at all in the client. And these are important considerations. They allow us effectively to build a hybrid full stack application ultimately with client and server elements inside SvelteKit. We'll get back to that though a little bit later on. For the moment, let's just notice some of the differences. Page load, page server load are different types of functions we would be writing. We're going to try both in our labs. That is, we're going to have kind of a hybrid application first, whereby the server-side element will be loaded in the server and then running in both server and client subsequently. And we're also going to lock down the server such that there will always be a server-side element that'll never run the browser, that'll always pass the data back to a browser-resident HTML page. So that's kind of it in terms of an introduction to SSR. The lab will go through it in detail. We'll turn donation into an application that is implemented using R. We'll specifically go for the page.server approach, whereby we will always have the page endpoints, as they're called, running on the server, passing data back to the client in the browser. It's not trivial to get working. As you can see, there's a little bit of complication into it. We're going to get into that now shortly in terms of how we deal with forms. It does, though, offer us some interesting possible innovations, in that if we take it a little bit further, we may be able to write our complete application in SvelteKit, dropping even the requirements for a dedicated API happy application. In other words, roll the entire full stack application into one framework, one project. We're returning now to technology we looked at a long time ago, cookies. Because we've got a server-side aspect now to our application via SSR features in SvelteKit, and cookies are managed from the server, we can reintroduce cookies to manage our sessions. This will eliminate quite a bit of the complexity we may have grappled with as we were saving tokens to our local storage and restoring them and so forth. So it does lead to some elegant simplification, but there is a little bit of code involved, which we're going to get into now. For this to work, we need form handling. And we're going to be exploring now how we do forms in this SSR world. And it will have quite strong resonance with the way we were doing it in Happy, in fact. That is, if we're implementing a form, we post data to a controller effectively in Happy. Well, it's very similar here. We're posting data to a function running on the server inside our page.ts files we've spoken about. So let's see what it looks like. First of all, we'll bring in a plus page.server.tss. So in the login component, we have an additional page, and this additional component will always be running on the server. And that's where we'll do the form handling and the cookie creation. In that file then, in page.server.ts, we can have a construct something like this. You export a set of actions, and each of these actions is a named method that will be triggered or called by some activity on the client. So it's very close in structure to the controllers in Happy. That is, somehow, as we'll see it in a moment, when we press the login button, we're going to have our data sent to this function here. And in that function, we can do the kinds of things we would do in a login method in general. So this gives us quite a bit of scope here. Specifically, we restructure the forms to be more traditional. That is, we have a form with a post method, and it has a path. And that path is going to be the name of the function on the server we'll be invoking. So this function, this string here, is used to identify which action is to be invoked. So instead of in the Svelte versions we've seen to date, the login button being handled locally by a button event handler running in the browser effectively, we're now skipping out here and posting the form data to the server and to a login method on the server. On that server then, it might look something like this. We're implementing the login function. The request is arriving as a parameter. We're extracting information from the request, that is, we're extracting the form data. And then if we've got the username and password recovered, we are proceeding to perform the login. Not quite doing that here, but let's see how we get the data. Request.form data. We get the entire form, and then we request individual pieces. We request the email and the password. They're going into these two variables, and presumably we're going to be checking these then against the database to see, is this a valid user or not. And we're doing that, of course, here. We're invoking the donation service, the same one we've been using in the past, and we're getting back a session if this was a valid user. We're now ready to consider creating a cookie. And the way we do that is here. That is, we're now manually creating a cookie, if you like. This is kind of automatically done for us, partly on the happy side. We're filling in some standard cookie parameters here, including the max age of the cookie, other security aspects of it. And this cookie will be created for us now on the server side and planted into the browser's cookie store. And we can see that if we open up the developer tools, we'll find the donation user cookie being created. This effectively is identical, really, to the way cookies are created in the Happy application. So zooming out then, our entire application now is being reconfigured. Every single route will have a page.server.ts. This, remember, will always run on the server. Therefore, it can recover the cookie information, and the cookie information contains important data like our session token, which we use to access the service. So most of our page.server.ts might be structured something like what you see here, page server load. First thing to do is load the cookie. So we are having passed to us by the framework a handle to access the cookie. If we do have a cookie, we parse it out. It's coming from the JSON format, which we're converting into an object. And then once we've got that done, we can access the token, which is stored in the cookie, and we can access our API as normal from here on in. So each of those page.server.ts will contain something like this and perhaps a little bit more. This code then becomes integrated into all our page.server implementations. Before we look at that, let's go back to how we were managing the session information before we brought an SSR. That is in the latest, the maps version, let's say, of Svelte, layout.svelte. Remember, what we were doing here is inside layout.svelte, which is the basis for all pages. When the page was mounted, we were calling restore session. Remember the function of this? Function of this was to check to see were we already logged in. And we did that by looking into the local storage via this method here. So local storage, remember, is a grab bag of storage we can recover from the browser for the application. We can see, have we saved the user here before? Yes, we have. Let's get the user's details out, name, email, password. And then let's use that to refresh the donation info to make sure we're logged in effectively. So this was a way of manually managing the sessions that we can now do away with, in fact. And we can do away with it by this layout.server.ts, doing exactly what we've just been speaking about here. In layout.server.ts, remember it's running on the server side, we're going to check to see if there is a cookie, and if there is, we'll pass it back. If there's not, the user is not logged in, presumably. So we're recovering the cookie information there. And back in layout.svelte, we should have the cookie information delivered to us, and we just recovered the session information there. So this session is being passed over to data, and we're going through it here, putting into the logged in user rune, email name, token and ID, all the session information. We're holding that now out in the client. In here, so for instance, in the charts page, our page.server.ts could be doing what we've just spoken about, recovering the session, and then we are doing refresh donation state back out in the client. So we're calculating here the donations by value and donations by method, for instance. So page.server.ts, remember, is running in the server. It's accessing the API from the server, passing back the latest donations candidates. These in turn are delivered out to data, and we're doing some more processing there in the client, updating some state information we think is important based on the data we have just fetched from the server. This leads to one more simplification. Layout.server.ts is doing the recovery of the cookie. That cookie can be passed on to all the page server TSs in the application itself. So in the charts page.server.ts, for instance, we're now no longer having to reach in to the cookie ourselves and do the parsing. We're getting the cookie information delivered to us via the parent parameter, and we're just taking that data directly here into session and doing our stuff. So that simplifies things significantly. It means that we are no longer responsible for reading the cookie in each page.server.ts. We are, in fact, having it delivered to us, and we're just using it then as we see fit. Particularly, we're using it in this instance to access the session token so we can make these API calls and get back our donation data. So was that worth all the extra work? Well, perhaps it looks a bit daunting to get through it, although the code, once we've implemented it, is reasonably straightforward. The layout.server recovers the cookies, pass the cookies to all the page.server.ts files, and well, we use the cookies there as we see fit. Usually we're just accessing the token so we can reach into the API and make invocations in an authenticated manner. Why are we doing all this though? Well, remember, when we're accessing the tokens, these could be sensitive. Or indeed, when we're accessing login information in general, perhaps we're trying to access API keys, or we're trying to access database connections, for instance. Well, in our previous approaches, any of those sensitive strings were on the client. They're ultimately rolled into the Svelte application itself. We now have those sensitive strings on the server only. And we'll see in our deployment options that we can put those into environment variables on the server and they'll never leak out to the client. That is one of the reasons why SSR in SvelteKit is considered perhaps a better approach, particularly when accessing databases directly. Okay, we'll keep exploring that as we go along. One last piece of this puzzle then is to get the donate form working. We've had a login form, remember, so we're posting information from the login form over to the server components. They're doing the login for us, they're setting cookies, and then throughout the application we're recovering and using the cookie to see who's logged in. Bit like how we were doing it in Happy. Now we need to change the donate form itself. So when we make a donation, we're using a similar mechanism. So let's see how that works. We're trying to look at form handling, SSR, using donate as our example as opposed to login. Again, we're posting the data in a conventional manner from the client to the server. Remember how it works to date using CSR, client-side rendering. That is the approach you've been using to date for donation. We have a donate function, And then that donate function is responsible for building up a donation and invoking the API directly. So we're doing that here using the logged in user token. So we're calling from the browser and invoking donate directly on the API. The whole event is triggered by the on-click event handler. So we're calling the donate function down here with a simple button that when the user presses it, we're going to invoke that function. To convert this to SSR, we get rid of the donate event handler in the client, and we have a standard form in the client, which is going to be routing through to a donate action, which is going to be invoked on the server. That donate action then presumably performs the donation for us on the server side. So instead of this, we're doing this. So this is the donate action here. It's living in page.server.ts. It's doing something similar, recovering the session, getting the form data, building up the donation, and then making the donation request using the session token. So we're doing a bit of work here, all on the server side, comparable to what we might be doing in a donation controller in Happy. That is getting the session, getting the form data, building the donation itself, and then accessing the API. One of the things we are doing is we're returning the new donation as the value of this entire function. So this entire function is returning a value, and it's the new donation we have just made. So this is the breakdown of it there. The request and the cookies come in, we recover the cookie, we get the session, create donation object, make the donation, return that new donation. Now, as part of HTTP protocol and the way forms are handled, there is an enhance function available to us whereby we can have a function called in the client, which will be past the return value from the action. This is a browser native behavior. It's not necessarily a part of Svelte, although Svelte is obviously taking advantage of it here. This means that our form method takes a function, and that function, we're calling it the enhance function, will be called if the donation is successful. And we're going to use that information to update the client. So this looks a little bit obscure on first contact, but whenever we're making a donation, this function will be called if the donation succeeds. There won't be a page refresh, so we are manually updating the state, if you like, of our application here. That is, we are getting the donation back, putting it onto our current donations rune, adding markers to our maps, refreshing the donation state. So there's quite a bit of work going on here to keep our state updated. We haven't refreshed everything. We've just seen that one donation has been added, and we're about to refresh our state based on that one donation. So this is the overall result then. Server side, make a donation. Client side, update the state with the latest single donation via the enhance function. The lab will go through this in detail, and you'll get a chance to see it in action. It's takes a little bit of time to get your head around it, particularly the use of the enhance function here. But this means that our application will be quite seamless in terms of its behavior. There'll be no full page refreshes. If we make a donation, we'll see little marker appearing, any adjustments if the charts are visible to the chart data and the report data and so on, effectively giving us a really interactive, reactive, responsive application. But we do have a bit of work to do, as we're doing here. The alternative to using the enhance function would be to do a complete refresh, which we're choosing not to do. We're choosing to just trickle out updates to keep our page live. Okay, that's more or less it for forms in SSR. We've got the login form, we've got the donate form. They're the only two forms in our application. Remember, what we're doing in these forms is we're posting data in a conventional manner, just like we did with Happy. On the page server.ts files, we're implementing effectively controllers running on the server all the time, which are recovering the form data and then maybe extracting cookie session information and then making calls on the API directly to make the donations or perform the authentication or whatever. Of course, that possibly does beg the question, could we directly access the database from those page.server components? Do we still need the Happy application sitting out there having to be maintained and secured, when in fact it's possible now we could consider accessing the Mongo database directly from the Svelte application itself? Particularly now that we've got SSR engaged and any keys or passwords for accessing the database could be held privately in the server aspect of the code. That's something we'll return to in the next topic.